Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is Poly-6, Multiplying Polynomials by a Monomial, Day 2. We'll start by reviewing the different types of monomials that you can find. If you look at the first one, we have a number of 7 as a base and an exponent of 2, and that's certainly one way that monomials can look. We can also have a variable as the base with an exponent, in this case still the exponent of 2. And what makes a base is the fact that it's connected to the exponent. So whether you have a number or a letter, if it's followed by the exponent, it's going to be the base. And then we can have a situation where both of those are combined, and our letter is still the base because it's connected to the exponent, but we have a number outside the letter, and that's called a coefficient. And those are all examples of monomials. When multiplying polynomials by a monomial, you need to remember that you're multiplying powers with like bases. So when multiplying powers with like bases, we add the exponents. So we have a to the m times a to the n. We keep a, and we simply add m plus n. So if you have numbers and not letters, you can actually go ahead and solve that. So we have x to the 4th times x to the 5th. We're going to get x to the 4 plus 5, or x to the 9th. And lastly, if we have coefficients attached to the bases, then we're going to keep the x's and add the variables just like we did before, add the exponents like we did before, and we're going to multiply the coefficients. So we have 2 times 3 giving us 6, and 3 plus 4 giving us an exponent of 7. We'll start by taking a look at question 2, D and E, which ask us to write each product as a polynomial. So we're taking this monomial out here and multiplying it by all of these. So the first thing we're going to do is multiply 3x to the 4th, y to the 3rd, by x to the 2nd, y. So as we use the distributive property to apply that, the 3 gets brought over, the x's get added, so we have a 4 and a 2, that gives us 6, and we have a 3, and remember this is assumed to be a 1, so 3 plus 1 gives us 4. And now we're going to take this same monomial and apply it to this. So we have the 3 gets brought over, we have no other coefficients here, so we have x's being added, 4 plus 1 gives us 5, and y's being added, 3 plus 2 gives us 5. And now we're going to apply this monomial to the last part of the polynomial, which is y to the 3rd. And as you can see, the only thing we're combining is the y's. The 3 and the x to the 4th get brought over. We have a y to the 3rd. Y to the 3rd gives us y to the 6th. Same procedure for E. We have a negative 16 that we are using the distributive property to apply to everything inside the parentheses. So if we multiply negative 16 by 3/4 c, one way you can think of this is if we divide 16 by 4 and multiply the answer by 3. So 16 divided by 4 is 4, times 3 gives us 12. It's a negative 16, so it's a negative 12. The c comes over. And then we're going to do the same thing to 5/8. Again, 8 goes into 16 2 times. Times 5 is going to give us 10, and it's 2 negatives, so that makes a positive, and the d just carries over. For number 3, E and H, you were asked to simplify. So the first thing I need to do is look inside my parentheses. Is there anything that can be done? There is not. I cannot combine x's and non-x's. So now I need to look at distributing the number outside the parentheses to the numbers inside the parentheses. So as I do that, I'm going to get 5 times 2 is 10x. And I have a 5x and a 3x. 3 times 5 is 15. It's negative. And the x's combine, because I'm multiplying, for x to the 2nd power. Each one of these x's is assumed to have an exponent of 1. And now I'm going to multiply this negative x over to here. But remember, I'm going to have to get the additive inverse of this, so it's almost like having a 1 right there. So as I distribute this, I'm going to get what I had, a positive 3x. I'm now going to get a negative 3x. The x's add up, squared. And I'm now going to get a positive 1x. I don't need to show the 1. I do need to show the x. So now I can combine these like terms. And while 10x is the start of this whole thing, I like to start with the largest degree. So I'm going to do the x to the second powers first. So if I combine the two of these, I have 15x squared minus 3x squared, negative 15x squared minus 3x squared is going to give me negative 18x squared. Then I can combine my 10x and my x to get 11x, positive 11x. Okay, same procedure over here. So the first thing I want to do is I have nothing to distribute outside these parentheses, and it may look like I have nothing to distribute here, but I've included this 1 simply because with a negative number I need to think about multiplying by negative 1 to change the signs or get the additive inverse over here. So I can bring down the a plus 3b, and I'm now going to get a negative a because before it was positive, and a positive 3b. And then once I have that, I can combine like terms. But in this case, I have a positive a and a negative a. They're just going to cancel out. And then I have two positive 3b's, which are going to work together to give me a positive 6b. Keeping in mind, I'm adding here, so I don't do anything with the assumed exponents in this case. So only when multiplying, not when adding. So my answer is going to be 6b. Please use the problems that were done for you tonight to help you solve any additional problems that are in your homework. And remember, the key to success in math is not only working hard, but working smart.